Hello Professor, in this presentation I would like to build the decision tree models and as well as a logistic regression model using a tool Weka. For this I'm using the liver disease dataset. These are the variables in the liver disease dataset, and the liver patient tells us whether the patient having this attributes is whether the patient is a liver disease patient or not. In this I want to change these two variables to nominal. So I'm making the changes. From numeric to nominal. I want to change the second and last, so that I've changed these two attributes into nominal. So let us apply the logistic regression model on this dataset. So I'm using the percentage split as 66 and the classifier is liver patient. So I'm running the model. So from this output we can interpret the coefficients, the betas, the coefficients of these variables in the logistic regression model, and the odd ratios. The odd ratios gives if the probability for a patient to be a liver disease patient, the odd gives the p minus 1 minus p by 1 minus p. The probability to be a liver disease patient divided by the probability not to be a liver disease patient, that gives the odd ratios here. And the accuracy rate on the test data set is 72%, as you see here, and the ROC area gives the area under the curve, the receiver operation characteristics, and here the confusion matrix is given below. So on building the logistic regression model on the liver disease dataset, I'm getting an accuracy of 72%. So even we are finding the true positive rate and the false positive rate for this logistic regression model. So let us go to the decision tree model for the same data set. For this I'm going under trees. J48 is the algorithm that we use to build a decision tree. For this I am setting the minimum object to 5 and the confidence factor to 0.75. These tells us the extent of to what extent the pruning should happen, and this describes the depth of the trees to be built. So let us build a classification model on this. If you find these are the attributes of a data set, and here is a tree that we found. See, the accuracy of the dataset fell down to 69%, and this is the confusion matrix here. So we can visualize the tree. This is the tree. Here the significant variable here is the direct bilirubin and the total bilirubin here. So we can find the estimation or the predicted variables based on the values of these attributes. So let us change the parameters. Keep it as to 0.25 and minimum object to 2. Save. See, the accuracy went up to 71%. For this logistic regression it is 72%. So more or less, both of the models are predicting more or less the same with a minute differences.